Hi everyone, this is Eric Vanderwall once again talking about Substrate. Now this part is not part of the Substrate recipes, but it is pretty much in every single Substrate recipe, and it certainly is something you have to know how to do if you want to write your own blockchain or your own palette or whatever else it is, and that's tests, writing tests. And I am horrible at writing tests, I admit it. I am not a test person, I never have been, I don't like writing tests. But it is necessary because short of like continuously going through your code again and again and again and again to run it, you don't know if you've introduced any errors. And unlike other things, if you're maybe in game development, your game crashes, it's like, oh well, that's not the end of the world. But when your blockchain crashes, that is a completely different thing. So tests. So I'm on the Substrate developer hub here looking at the documentation. And basically, go ahead and come read through this. I'm not going to read through it with you together. It basically tells you how to set up your test environment and how to set up your Genesis block if you need one and all that kind of stuff. But I highly recommend you start off not worrying about that and instead copy and pasting from another test, because you will get so bogged down in writing all of the use statements and setting up the blocks and everything correctly for testing that you won't get any testing done. Now I'm in the recipes here like I normally am. And if we check any of these recipes, for example, I'll just open up double map, open up the source, and you'll see that there is a test included in this one already. And basically we can just copy and paste out everything before the test starts. So here's the first test, and you can see it's marked with test. We can just grab all this, and we could copy and paste this out into our own test. That's the best way to start, and then just modify these as necessary. If you're using extra things that you don't need to use, the compiler will give you a warning and say you don't need to use this, but it's not going to throw an error, or your tests are not necessarily going to fail just because you have extra using statements. So that's good. But as you can see here, I'm going to go back to mine. So this is a custom module or a custom palette that I wrote, and I'll try and put this up on GitHub and link it for people, just the palette itself. So you'll still have to add it in. But I added a very small library of functions here and tests just to show you how the different tests work. But okay, looking at this from, I guess, the start, is if we have a palette, we need to go to the palette's library first and make sure we add this attribute. So an attribute is something that starts with a hash and opening closing parentheses that are square, and then we type in whatever the attribute is. So these are like predefined. So we're adding the attribute of CFG, and then we're going to add in test, and then add the name of the test file that we're using. And by tradition here, we're using a test file named tests. So these are all their test files are named tests. They don't have to be, but this is just the way it typically is done. This should be the only thing you're going to need to modify on your actual library. After making any changes in the library we can go ahead and add a test with an S at the end, .rs file, and copy and paste in this whole like header section that we got from another test. And I won't go over most of this. It's fairly standard across all of the tests here. What you may need to add into your construction runtime, so this is essentially a testing runtime rather than what comes from your normal runtime. You might need to add in for your palette, whatever your palette is using here, such as I'm using the module, which they all use. I'm using calls, I'm using events. These are generic events. You might have to have storage in here, or everything else that you're using. So go ahead and add that in. But otherwise, most of the things will probably be very similar. If we look here, we've added a struct that says Externality Builder, mouthful, and we've added an implementation of the Externality Builder. This could be called whatever we want, this struct. It could be called Booger Builder. But what this is going to do is it will actually build up our test environment as well as add a storage environment here, and we've got our Genesis block configuration for testing set up here. And the way that it's written here, you don't really need to understand it. You just need to understand that this is here to build up storage. And when we go down to our actual test functions, you can see that they're always wrapped up in this struct. All our tests are wrapped in this struct. So let's look at actually writing a test. So each test is an individual function and should be first have the attribute test. So the system knows it's a test. Then we're going to give it a function name. And we don't need the test to return anything, so we're just going to have opening and closing brackets here. And we're going to add these squiggly parentheses. And we shouldn't have any errors. Now the next part, I suggest you just copy and paste. We're going to copy and paste this part because it's going to be in every single test. Just this part here. Now once we're inside, this part will be unique for each function that we want to write. So don't forget to give it a comment to the top so we know what it does. We can use 3 and just say, this is my simple test. And you will notice, as with most things in Rust here, this is not in any specific class because we don't have any classes. It's not any struct. So if you go down, basically the last function is just at the end. There's nothing closing this whole thing off. Okay, so in this part about tests, I'm going to make a few parts because I'm going to get more or progressively more complicated with the tests. We are just going to do basic assertions, and we're going to look at tests for events. But we can do tests for all kinds of things, like tests for storage, tests for events, tests for errors, tests for all kinds of things. But we should just sort of build our way up there about how to manipulate those tests for Substrate. And the first one we're going to do is just use the assertOk macro. And you can see it right here. So it's in the middle of this wrapping that we need for everything. And we're going to use this macro called assertOk. And to make sure that this assertOk macro works, and you can see other ones in blue here, like assertErr, which we'll be using in the future, we need to make sure that it's added to the frame support at the top. So you can see I have assert no-op, assertOk, and assertErr in this one. Without it, these won't work. You're going to have an error when you try and run this. So make sure those are added up there. And let's see what I wrote in my comment. AssertOk macros checks that an OK is returned from the function. If an OK is not returned, then this test will fail. This function, say, shows to pass a signed user, an origin, into a function. Okay, so let's just do it. We're going to type assert underscore OK and exclamation mark, and we're going to put our statement in here. And this statement needs to return OK from the function. So this function lives in the library itself. So let's go to library. We want to check this function. It's called assertOk function. Let's go have a look at it. I'll just scroll down. There's nothing really special going on here. And this is a very simple function here. The only thing is that we call the function and pass it the origin. It checks the origin as OK, or signed, and then it calls OK and passes this back to the dispatch results. That's all this function does. I don't think we can have a more simple function. It just meets the criteria of what a function has to have at the very minimum. So as long as the origin is the signed origin, there will be no error, and then it will return OK, and that's what we're looking for. So back to the test, we have to add the name of the palette, colon, colon, then the name of the function, and then we're going to pass it the value. So let's try that. We'll go the name of the palette, tests, colon, colon, the name of the function, and my IntelliSense hates me here. And then we have to pass in a value because when we're using the extrinsic calls from the website, which is polkadot.js.org/app, like you saw in a much earlier tutorial, it automatically passes in the origin because you're signed into an account, or essentially you're signed into a mock account such as Alice or Bob, right? So that origin is passed automatically for you. But however, because we're writing a test, we're not signed in as any specific user, so we need to tell it manually to pass in a signed user. So we're going to say origin ::signed, and we're going to pass it in a number. So this would be a user number. So when I'm doing testing, I'm just going to pass in user 1. So it's going to run this function and pass one argument, which is user 1. Okay, we'll clean this up a little bit. Now, using most IDEs, you can simply push the play button here to run just this one test, and your IDE is going to help you interpret the results. So I'm going to click it and then say run test. And it may want to do something first here. So it's throwing an error saying this test above, my simple test, is invalid. Fair enough. Run this again. And it's just going to take a second to build. Okay, now it's throwing some warnings here, such as I have unused variables and things like that, which is fine. When you're in development, you're going to have lots of unused variables. But before you ship something, of course, you want to make sure that these are all fixed up. Okay, my test completed. I'm going to scroll down to the bottom and see, okay, we had 3 warnings emitted. Finished tests in 0.18 seconds and no problems. Process finished with execode 0. Execode 0 means okay. Now on my IDE and Visual Studio Code will be a bit different, but it's pretty similar, I'm sure. Is we can see tests, and then the function that we actually ran was assert is okay. And it doesn't have any actual information here for me because it just returned okay. We'll see other tests have more information for us, but it looks good. Okay, let's keep looking at our tests. Okay, we'll just build upon this. In this example, we see that not only the origin can be passed as an argument, but also other parameters. So in this case, we are going to be looking at a function called assertOk over 100 function. So we'll go back to our library and we will check here. And we can pass a second argument, which is just a number. Okay, so we have some events here. We can just ignore this for now. We'll be looking at these events later. But really, they should be at the bottom. That's where we want our events. Okay, so what we're going to do is make sure that this number, whatever we're passing, is over 100. If it's not over 100, we want to throw an error. Else an OK. So if my number is greater than 100, pass OK. Else, we're going to throw an error message. Now, we haven't covered error messages in particular because there's a couple of different ways to dispatch error messages in the system. And we'll look at that in another one. But if you follow along with the other palettes in the recipe so far, you're probably already familiar with this, at least a little bit, enough to copy and paste it in. Now, like before, we said we don't want to use the if-else statements. I want my OK to be at the bottom and instead to short circuit as it goes down. So I'm going to go ahead and just, well, I'll comment this out so we have it here for later. Instead, we're going to use a statement here, which I think we looked at slightly earlier, in an earlier tutorial in the storage map tutorial, right? So we can use an ensure macro that says, as long as this returns true, then continue down. If this doesn't return true, then throw this error. So we have an error here, and I just called it my error. So then I've got two events here, which are just events that we'll look at later. And then we'll return OK. We'll go back to our test here. And assert is OK over 100 is the name of my test, not the name of what we're calling. So we want to assert is OK, that this function returns OK or throws an error. So here I passed a second argument, which is 101, so that's over 100, so this should work. So we'll click play. So when you're writing your test, you want some tests to fail on purpose, and we'll look at that. And you want some tests to pass on purpose. And what we're looking to do is just push, our code, poke our code, and make sure that it's returning reasonable values and that no errors are throwing. It's impossible to test for everything, of course, but we should test for, as the reasonable normal usage as well as those edge cases, for example, where we're passing like huge numbers or unreasonable things that people might do with your code that you may not expect. Okay, let's check here. And it ran correctly, everything passed, we had no problem. So let's see what it looks like if we have a failure. So if I change this to 99, it's under 100. I click play here and run this test. And here we can see we have a failing test, and it has more information now that we actually had an error. And we can look at these backtrace logs and stuff like that if we want to, try and figure out more specifically what the error is, but we know here. So let's change this back so my test will pass the next time we run the code. And we're almost done. We're going to try not to keep this too long, which is definitely why we're going to break this up. Okay. Assert error macros. So we're looking at another macro. Assert error macros check that errors occur when they should. Feed the function an argument that you know will fail and return an error. The second argument of the assert error should be the expected error to occur. Okay, here we're running the same function as before, which is assertOk over 100 function. And instead of using assertOk, we're using assertError. We're passing in the same values. And instead of passing 101, I'm going to pass in 77. So we know it's going to fail. We're trying to make it fail. And here we have the name of the error that we want to see. So this error should return. So let's just run this first, and then we'll break it. Okay, so my test passed, but what if, for example, we didn't have an error? What if it returned successful? That's not what we want from this test, but... And I don't know if Visual Studio Code does this, maybe you guys can let me know, but on IntelliJ products, you have a left-right, and you can click the difference. And so the left shows you what you actually got. The right is going to show you what you expected. So we'll click to see the difference. So on this line, this is what we expected to see, and this is what we got. So we can see we got an OK result, and that's not what we wanted. So we want to make this fail on purpose. Okay, so the next question is, how do we write the correct error in here? So we go back to the tests, and if you've worked with errors at all, you'll know that we have a declare error section. And the error that I'm throwing is just this one called my error. Go up. It's not very descriptive. Don't use errors like that. Okay, assert my function is over 100. If it's not, ensure. So we're going to throw an error. So we'll just copy and paste the way the error is written here, which is error, which is always going to be the word error, dot, 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 type, dot, 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 and then the name of your error. Okay, so we'll go over to the test, and we'll just paste this below so we can see how it looks compared. And you can see what the difference is here is we've pasted in this test runtime, because we're using a test runtime. And as long as you do that, it will be in the right format. So the same format as before, we just change T for type to test runtime. Okay, in this one, we can also pass in the root user rather than a normal signed user of the blockchain. If the function is expecting a signed user rather than the root, the function will fail and return a bad origin error. So sometimes you might need to check to see, because we have three types of users. We have root, signed, and unsigned. And for me, it took a little while to figure out how do I pass in the root user. So we're just going back to this first function which we use, which is assertOk function. We're just basically passing in a signed user and then returning OK. But we're going to assert that this is an error. We want to make sure that only signed users are going to go in, or we're going to throw an error. So how we can get the root is we have to type raw origin ::root, and then we're going to do .into to cast it into the right type. Then it's going to return an error called dispatch error ... bad origin. So how did I figure out it's going to return this error? This is the one. Is just because I put in the wrong answer here and then see what it returns to me. So let's play this. So it is going to throw an error like it should, but it's not going to come back with this error. Okay, so the left side passed back this, what we expect, and the right side is what we wrote, was this. You can see the difference here. So that's how I know which error to expect. And how did I know the exact syntax of typing in? Honestly, I just did it a whole bunch of times until I figured out the right syntax and browsed other code. It's not a super elegant way to do this, but it worked. So this is the right way to write this error specifically, the right format. Okay, now let's talk about events. Before we were just checking for OKs or errors, but now we want to make sure that our events are correctly done. In this test, we first construct a generic event and then compare it to the events from the system results. A mismatch of arguments will result in a failing test. So let's look at this. We are going to first make a number. So let my number equal, say, 105. Then here we've just done our normal assertOk test. This is just like the test above. We're going to run the function and say assertOk is over 100 function. So we're going to pass it the normal user, and we're going to pass it 105. So this should pass back OK, no problem. Now this part is new. First, build the event we want to check. So we want to compare the event that comes back from the system with something. Well, how do we compare that? We don't have anything. So first we have to build an event manually and then compare those two things. And we're going to save that an event into a variable. So we're just going to say let the name of our variable equals, and we're going to say event tests. And now this is our argument. It's going to be right here. And to get this event, we're going to go back here. Check our events. Okay, so we're running this function here called assertOk over 100 function. We're checking the first event that's coming through, and it's called raw event emit input 32 with my number. So if you don't know how to work with generic events, go watch that tutorial first. Okay. And so, oh, by the way, this is the name of the palette. So event, which is always the same, : the name of the palette, then opening, closing parentheses, then the actual event itself, and then we're going to pass in the variable because we're making up the number here. So 105, and save it as a variable. Okay, now we need to compare the two. So we're going to assert that these two things are equal. We haven't used this before, but everything on the left side and the right side of this comma should be equal. So on this side, we have the expected event, which we just created, so we know what that is. On this side, we need to capture the system event. So we're going to type system, it's always going to be the same, : events, opening, closing, then a square brackets, and inside that we're going to put 0 here. The 0 meaning the first event that gets fired from this function. So we're going to call the function here, build our event, compare the one that's fired off with the one we built, and assert that they are equal. So let's hit play. And it returned back true. We had no problems with this. So if we gave it, for example, another number into the event we constructed, say like 88. Oops. So we're passing 88 into our made-up event that we're constructing. But when we're calling the actual function up here and assertOk, we've passed it in my number, which is 105. So this is 105. So when we compare these two events, now they shouldn't be the same because the event contains the number coming back. So we can click to see the right and left difference, and here 88 came back and we were expecting 105, or sorry, the other way around. This was expected, this is what the actual answer was. Let's just undo that. Okay, the very last one, you can take a deep breath here and then we're done for tests. So check the second event emitted by this function. If we go back to the library and look at it, I actually made 2 return events, and it's really unnecessary to do this, but sometimes you might have more than one event coming back and we need to check the second one. So this second event, I've just returned the number that's passed through as a variable and added 5. So we'll go back to the test and we'll look down. And this time we're doing just the same. We're going to assert OK, run the function, build our own event, and this time I'm going to pass a number plus 5 because that's what we're expecting. And when we assert equality, instead of using 0 for the first event, because this is like arrays starting at 0, we're going to use 1 because we want the second event, and this will return OK. So in this way, we can check various events as long as they're in order. So if you're not familiar with testing, this is probably maybe a lot to take in and sort of conceptualize like why you want to do this, other than the surface idea of like, okay, I need to run tests. So which tests you need to run is a bit of an art. There are no hard and fast rules about how you need to write your tests. But for every function that you have, you really should test it at the very basic level, at least. And I will add some more test tutorials here as we go along. It may not be the next tutorial I do, but I'll slowly try and add some more as we'll learn how to test different things, because I don't think, or I don't feel it's that, I don't know what the word is. I can't use the word natural, but it's not like you just naturally know what to test or why or how to do these. Like, how do you check the events? How do you check the OKs? How do you check the errors? It's not like you can just know it, right? So it is in the documentation to a certain degree, but really the best way to learn how to do it is to simply check all the other test palettes and see, okay, this one is using a double map. How do we test a double map? We gotta go here and then check the function that uses the double map and to see how they're testing it. And we see, okay, this is a double map in here and it's using in this assert no op. So now we need to figure out, okay, how do we use this assert no op? And a really cool way to do this is we can just like copy and paste this. And depending on your IDE, you're gonna be able to find this somewhere. We're gonna go find, and we want to find in file. So this is Control-Shift-F in IntelliJ. And this is what we're searching. And now it's going to show me in the entire project all the places that this is used. And now we can find lots of examples of how this is being used, right? And this will help us to figure out, Okay, that's how we might use it. This is where we might use it. And this is, one of the main ways that I'm learning how to do this is just by like going through the code, looking up every example that I can find, checking the documents after and saying, okay, that looks right. Let's run it again and again and again until we know that it's working. And then once you've done that, if you're still not clear, then go to, the different channels like the Matrix channel or the Discord channel for Substrate, and then reach out and ask and show them your code then. So try not to go there first off and just sort of ask, hey, how do I do this? But instead go and look into the code as best you can, find the examples of where it is, try and run it. If it doesn't run, make some adjustments. If those adjustments don't work, then go and say, okay, this is what I've got. And people will be much more willing to help you because they've seen what you've tried already. Okay, so that's it for test part 1. Don't expect test part 2 right away, but hopefully this gets you started on writing tests in Substrate. Please don't forget to give me a thumbs up and a like, a comment especially, if you've actually made it this far in this tutorial. I know testing can be a little bit dry, but it is necessary. Okay, until next time.